From the beautiful studios of Way Happy, this is Mr. Meyer, and let's talk real quick, at least about sine and cosine. Now, we told you the derivatives of sine and cosine in an earlier video. We just stated them, we never actually proved them. Now we can take a few moments to actually prove what these derivatives are. So let's say that you want to take the derivative with respect to x of sine of x, our good friend sine. Right? You want to take that derivative. So that's how it looks. All right, well, the only way we really can do that then, if someone has just told us we have to take the derivative, is we have to prove it. The only way we can actually do that is do the limiting process. So remember our good friend, the definition of derivative is f of x plus h. Well, f of the function is sine, so sine of x plus h minus f of x minus sine of x, right? All over h. That is what I have to sit here and prove. So let's do it. Now, go back to your pre-calc days. Do you remember what two angles added together for sine? What would happen? Well, it would be sine, cosine, cosine, sine, of course. So the limit as h heads to 0 of sine, oops, don't go up there, pen. It's been that kind of night. It would be the sine of x cosine h plus cosine x sine h minus the sine of x all over the letter h. Now it gets a little interesting, right? Because now you're just kind of like, all right, but there's not much there to do there. So best thing I can do is I can see that there's a lot of h's in here, but I have a sine x and a sine x, and so let's at least get those together so we can factor that out. So I would have something like the limit as h heads to 0 of sine x cosine h, I'm getting a little sloppy, drop my parentheses, minus sine x plus cosine x sine h all over h. Now, the reason I did that was because then it would be really nice to factor out a sine x. So I'm going to factor out the sine x and be left with cosine h minus 1. What do I got? Plus, over there, nothing can factor out cosine x sine h. So I guess I'll just leave that all over h. Now we have, two fractions here that are added together because they had a common denominator. Well, it would be much easier to do this limit if they were separated. So I want to separate them. So I have sine of x. And remember, if you separate two limits, you can add those two limits together. So I'm going to have sine x cosine h minus 1 all over h. And then the other fraction would be cosine x sine h over h. But it's going to be the limit of that. So I'm going to take the limit of that because, I forgot my h is head to 0 here. So I just really took the two fractions and I broke them apart into, one fraction into two fractions. And then since it's the limit process, well, I can just add those two limits together. Now here's where it gets super cool. You can notice that this right here has an x in it. It doesn't have an h in it. So therefore, it's not affected by the limit. It's just a constant, and it could come out front. Same thing with this cosine. He doesn't have an x in it or an h in him, so he can come out front too. So look at this magic. I can say this is equal to the sine of x, because it doesn't have an h, and then the limit as h heads to 0. So it's a constant. It's just a number that comes out front. The limit of cosine of h minus 1 over h. And do you know, we know that limit. This limit, my friends, heads to 0. But we're not done. Over here, we have a cosine of x that can come out, and we still have the limit as h heads to 0 of sine h over h. And we happen to know this thing heads to 1. So really, if you think about that, we just have sine x times 0 plus cosine x times 1. And all that would be left is the cosine of x. And thus, you have proven that the derivative of sine is cosine. And now, example 2, I would do, but my pen is driving me nuts, so I'm not going to. But it's the same thing, and you will notice that you'll have a negative floating around in there, and you will end up getting negative sine. So that's how you guys on your own could prove. Once you do the exact same process, you know the answer is negative sine. See if you get it, right? And see if you get the same thing. And then let's do tangent, because why leave tangent out of all this? Well, now we want to find the derivative with respect to x of tangent. All right, that should be easy enough. Wait a minute. Instead of using the limiting process, why don't I just change tangent to sine x over cosine x? And then, wait a minute, there was a rule for fractions. Wait, this would be a really good question to do at the end of this video. Stay happy. I'll see you tomorrow.